Earth, our home, appears to us as a tiny blue speck adrift in the boundless expanse of the cosmic ocean. This fragile abode holds everything we hold dear, every human being who has ever lived, every story ever told. It is here that our extraordinary journey begins. Yet, as soon as we rise above Earth's atmosphere, past the moon, sail beyond the orbits of familiar planets, even beyond the sun, our voyage transforms into a grand quest, a quest to grasp the true scale of our universe. Leaving Earth's comforting embrace, we first encounter the moon, roughly 384,000 kilometers away. That distance is so vast that, traveling by car at a steady 100 kilometers per hour, it would take over 160 days to reach our celestial neighbor. From this lunar vantage point, Earth appears as a delicate blue-green sphere suspended in the infinite blackness of space, a sight that humbles us with a profound sense of our place in the cosmos. This is how Earth looks when viewed from the moon. Continuing our journey deeper into space, we arrive at the sun, the next great milestone, situated about 1 astronomical unit, AU, from Earth. 1 astronomical unit equals approximately 150 million kilometers and serves as the standard yardstick for measuring distances within our solar system. Consider this: light, racing at an astonishing 300,000 kilometers per second, takes about 8 minutes and 20 seconds to travel from the sun to Earth. If a commercial airliner flew that same route at 900 kilometers per hour, the journey would last nearly 19 years. This staggering distance is a vivid reminder of the sheer immensity of space, even within our own cosmic backyard. The sun, that fiery giant, sustains life on our planet from an almost unimaginable remove. Venturing beyond our home planet and its stellar companion, we head toward Mars, our enigmatic red neighbor. At its closest approach, @, meta, quote, pause, quote, colon, quote, sex, quote, colon, 2.06 million kilometers from Earth. But when the two planets sit on opposite sides of the sun, that distance swells to roughly 401 million kilometers. To put this in perspective, a trip to Mars aboard a commercial jet would take more than 50 years. The vast emptiness between Earth and Mars presents a formidable challenge for space exploration. The rovers and probes we dispatch to the red planet embark not only on long journeys, but also on complex missions dictated by ever-shifting distances and orbital mechanics. Pushing toward the outermost reaches of our solar system, we encounter Neptune, the distant ice giant located some 4.5 billion kilometers from Earth. Neptune marks the edge of our solar neighborhood. Sunlight racing through the vacuum of space requires about 4 hours and 15 minutes to reach Neptune from the sun. This mind-boggling distance reveals just how colossal our solar system truly is. SEX 2.0. Launched in 1977, the Voyager 1 spacecraft embodies humanity's insatiable curiosity and our drive to explore beyond known boundaries. Now, after more than 4 decades of travel, Voyager 1 has journeyed over 22 billion kilometers from Earth, making it the most distant human-made object, a silent wanderer in the cosmic sea. In 1990, at the urging of renowned astronomer Carl Sagan, Voyager 1 turned its camera back toward Earth for one final photograph. From a distance of roughly 6 billion kilometers, our planet appeared as a faint, pale blue dot against the vast backdrop of space. Sagan reflected poetically on this image, underscoring our duty to cherish and protect our only home, a mere speck in the immensity of the universe. At the very fringes of our solar system lies the Oort Cloud, a vast theoretical sphere of icy bodies thought to stretch as far as 100,000 astronomical units from the Sun. That's nearly 1.9 light years. So immense, scientists define the edge of interstellar space by the heliopause, where the Sun's solar wind is halted by the interstellar medium. Beyond this boundary, the Sun's influence ends, and the true expanse of interstellar space begins. The Oort Cloud thus marks the final frontier of our solar system, a threshold where the Sun's grip fades and our journey into the galaxy truly commences. Once we leave our solar system behind, our next landmark is Alpha Centauri, the closest star system to our Sun. Located about 41.3 trillion kilometers away, or over 276,000 astronomical units, such distances render the astronomical unit impractical. Astronomers instead use the light year, the distance light travels in 1 year, for interstellar measurements. Alpha Centauri lies roughly 4.4 light years from us. With current spaceflight technology, reaching it is almost inconceivable. Voyager 1, traveling at about 17 kilometers per second, would require more than 70,000 years to arrive. This immense gulf highlights the staggering emptiness between stars and the profound challenges of interstellar travel. Our journey now expands to the majestic scale of our home galaxy, the Milky Way. This vast spiral galaxy spans about 100,000 light years and hosts hundreds of billions of stars, each potentially orbited by its own planetary systems. Within this immense structure lies a tiny sphere known as the human radio bubble, extending roughly 100 light years from Earth. This bubble marks the farthest reach of human influence, the limit to which our radio and television signals have traveled into space. Beyond it, humanity might as well not exist. Civilizations residing in the overwhelming majority of our galaxy remain unaware of our presence, as our signals have yet to reach them. The scale of the Milky Way is so vast that all of recorded human history amounts to little more than a whisper in the cosmic wind. Meta, pause, sex 2.0. As we depart the Milky Way, we enter the vast, almost unfathomable realm of intergalactic space. Here, galaxies drift like islands in a cosmic ocean, separated by mind-bending distances. Our galaxy belongs to a small cosmic neighborhood called the Local Group, a cluster of more than 50 galaxies spanning roughly 10 million light years. This diverse assembly includes not only grand spirals like the Milky Way and Andromeda, but also numerous smaller dwarf galaxies. Distances here are so immense that light would take 10 million years to cross from one end of the Local Group to the other. This scale dwarfs everything within our own galaxy, underscoring the universe's staggering immensity. Intergalactic space is a silent void, an immense desert between islands of galactic light. In this boundless emptiness, our galaxy, home to all of human history, is but a tiny fragment among countless others, a single story in a grand cosmic library. Expanding our cosmic perspective beyond the Local Group, we encounter the colossal Virgo supercluster, a vast assembly of galaxy groups and clusters, including our own. Spanning roughly 110 million light years, or 33 megaparsecs, The Virgo supercluster is a titanic structure containing thousands of galaxies from at least 100 distinct groups and clusters, each with its own countless stars and planets. Venturing further, we reach an even more astonishing cosmic structure, the Laniakea supercluster. This immense galaxy supercluster encompasses the Virgo supercluster and stretches over 500 million light-years. It is our galactic home on the grandest scale. Laniakea, Hawaiian for immense heavens, lives up to its name, containing a mass equivalent to 100 million billion suns. Laniakea is a gravitational masterpiece, a cosmic web in which galaxies, clusters, and superclusters @ meta, quote, pause, quote, colon, quote, sex, quote, colon, 2.0. At its heart lies the Great Attractor, a mysterious region exerting powerful gravitational pull on galaxies throughout the supercluster. Within this vast expanse, the Milky Way, the entire local group, and even the Virgo supercluster are but minute components of a structure far greater than we can fully comprehend. Laniakea offers profound context for our existence. Within this colossal supercluster, we are part of something vastly larger and more majestic than we can grasp. At the outermost edge of our cosmic exploration lies the observable universe, an astronomical marvel roughly 93 billion light-years in diameter. This raises a compelling question. If the universe is only 13.8 billion years old, how can it be so enormous? The answer lies in cosmic expansion. Since the Big Bang, space itself has been stretching, increasing the distances between celestial objects. But what lies beyond the observable universe? This remains one of cosmology's greatest mysteries. Some regions of space are receding from us faster than the speed of light, forever beyond our view. Thus, the true size of the entire universe remains unknown and may well be infinite. The observable universe, vast as it is, could be just a tiny fragment of all that exists. We are left with a humbling realization. There may always be regions of space, entire galaxies, and cosmic wonders we will never see, as they vanish forever into the depths of an ever-expanding universe.